They take a few minutes. So 512, that's important for testing. 512 is the default encryption size. The higher the number, the harder to decrypt it. So obviously you want to make it what? Difficult for the hacker. So you want to go with the highest number if your equipment won't take hours to produce the key. We're using a simulator, it goes pretty quick. So since we're using a simulator, we're going to do 2048. But with real equipment, this could take, depending on what equipment you're using, could take actually a long time, 30 to 40 minutes to create. You're sitting there thinking something's broken, but it's not. It just takes a long time to create this huge 2048-bit key. Okay, so but it's a simulator. It goes pretty quick. Again, 512. If you just hit enter here without typing any number in, if you would hit enter, it would be 512 because that's what the default is. Does that make sense? Mm-hmm. All right, hit enter. It says generating, okay, 2048-bit RSA key. Keys will be non-exportable. They're for that domain only. You cannot export keys. That would be a security breach. So far, so good. This is what encrypts it. This was now what we encrypted. We're using RSA. RSA is a hash function like MD5 and MD7, just a much more powerful one. Okay? You remember we talked about hash functions? Hash function basically is a mathematical algorithm. We don't want to even get into how that works because that would drive us insane. We could talk about it for hours. And in reality, it's actually just for mathematicians probably get excited about it. I don't think we would. Okay, but what happens is it scrambles it in all these bits and adds a different world. So the longer the number, the longer that thing is going to be. Even though Cisco is about this big, it's going to look like this when the hacker gets it. Good luck with that. All right. Now a 2048 with a high-end computer would take consistently 3 months of running to be able to crack it. Yeah, and then of course, if you have good password policies, you probably change it since then again. Because you're not supposed to keep it more than like 30 days at the most, 45 maybe max. Okay. So anyway, any questions so far?
Everything we've done since we hit exit has been just SSH.
Everything. Yeah.
We're still in SSH.
We haven't even done the telnet part for it yet. Yep. We're creating the SSH technology. We even haven't set it. We haven't attached it yet to the telnet portion yet. Not yet. Okay. It's about to come though. Okay. So that's it. If there are no questions, that right there prepared, in this case, our router in this case, to be SSH compatible, ready to go for SSH. Now we're going to take that SSH that we created, the secure shell, and we're now going to attach it finally to the telnet session. Okay, so again, line space VTY space 0 through 4. We remember that one, right? Hit enter. Look what it says, SSH 5 enabled. All right, so it realizes, there's some SSH going on already. Okay. Now normally, what I'm about to type in, we would not do if this was a real environment. Okay? What I mean by that is a real environment means we would have a server that would have a database on it. You remember what a database is? Like Oracle database or SQL database. Have you ever heard that before? Those terms? A database basically is a computer, or a database is a software with a lot of fields, and those fields are populated. Like your customer service get people when they have a client call in, they ask for the customer number. Yeah, they type that in. It goes to a database and finds it loaded. That's what a database is. A database lets you search fields, last name, telephone number, whatever, to find something quicker. That's what a database does. Okay, so if we were doing a Microsoft class in addition to this networking class, we would actually have an SQL server running, and that would be basically where we would actually have our sessions logged. But we're not in the Microsoft class. So I can use my router to become my database server. Not good practice, but we're in a Cisco class, and so for the Cisco class, it's okay to do it. But in the real world, you would have actually a server, a real server. So remember a real server, what I mean by a real server? A box, a computer, that would actually act as your database server. Could be Oracle, could be SQL. But in this scenario, we're using our router will become now what? Our database for it, because we need to track our sessions, our SSH sessions. and we have to put that into a database so we can track it. Does that make sense? Log it. Yes? Good? So the command is, it's still login. You remember that one, but instead of login, you do login local. That creates now a database on this local machine, in this case CR1. Good?
You'd have to do the password first?
Nope, not yet.
Okay.
You hit enter. Then we do password like we always do, but this password is going to be for what? This is going to be for the telnet session. So this is not the password that would SSH would use. SSH would use that password I used in the username password combination up there. It happens to be the same Cisco, so we don't want to remember thousands of passwords, but in the real world you wouldn't do it that way. Your SSH password would be different from the telnet password. Should be different.
Well, with the SSH, you'd have a username also.
What's that now?
With the SSH, you would have the
A username anyway,
as well.
right? As well. Here you don't.
Right.
Telnet you don't. But you still don't want to make it the same password for security purposes. But so we don't have to remember thousands of passwords. We're going to keep it Cisco. Does that make sense?
Robert,
Yes.
going back to the login local, if I wanted to put it onto the server, would I put login and then put the IP address for the server?
No, just log in, and then you would go to the server,
Yeah.
and you would set up actually the server there, and it would actually find it automatically. That's how powerful it is.
Oh, okay.
SSH would find that you have a server, a SQL server, Oracle server, whatever you end up having as a database server.
Okay.
Yeah. So you don't actually have to point it. It finds it.
So you just put login.
Login, and it knows then the look. That tells it it's not local to that little machine. It looks for it, finds it. Oh, there's a database server, Oracle. Well, not magical, but it signals that it's broadcasting for a server to come back to it. Does that make sense?
Yep.
So you would just do the regular login. You hit enter, okay? And this is now where we change it from. Right now, it's still telnet. This line right here attaches now SSH to the telnet session. The command is transport space input SSH. Hit enter. We have now just basically attached SSH to the telnet session with that one line. Transport input is using SSH. So you're basically telling you when we're transporting the information from point A to point B, it will use what? What's the input going to be? SSH. So transport space input space SSH. All right, that's the first security thing you've learned now. It's a lot. Security is not as straightforward as some of the other concepts we've learned. But I hope that I actually was able to break it down so it doesn't sound that complicated. But nevertheless, are there any questions? So that first part, just to review, that first part is actually setting up SSH at the global config mode. The second part we just did is just doing a regular telnet setup and then attaching SSH to the telnet setup. Does that make sense? That one line basically, and the only reason we really did the login local is because we don't have an SQL server. Normally, that's not what we would do. Most people would never use their router to be their server. It's not good practice. But we have to do what we have to do in a networking class to be able to make it work. So we would just do login, like Dan had mentioned earlier.
So you just put login if you did have a server.
Correct.
And it'll go look for them.
Mm-hmm.
Oh.
Correct.
So now, if you were going from a computer to telnet, to get on remotely, what would you type in? Would you type in telnet? Or
Nope.
So what would you type in?
I will show it, but I can tell you. You would type in SSH space -L, which means SSH login.
Okay.
The L stands for login, space, the username, so R more in my case, space, and then the IP address for the device you're trying to log into. Let's say 172.16.1.1. Hit enter. Then the password will be prompted. Then you type in the password of the SSH session, not the telnet one. Okay. Now, in order for also telnet to work, I would have to actually put a second line, transport input telnet, for both SSH and telnet to be there. Right now, only SSH is implemented. If I needed to use telnet as well, which I may want to do internally, I would have to now put a second line in, transport space input telnet. That means I have both SSH and telnet available to me. At this very moment, I do not have telnet available to me. If you try a telnet session right now without adding that line, you would not get, telnet would not work. It would say timed out or session closed by foreign host. We do not want to use telnet because we're practicing security here. So we're not going to turn it on. I think it's even turned off. I think I've tried it. It's turned off. If you try to type it in, it won't work because I don't want you to use it. We're supposed to get used to SSH. But I want to make sure you understand, if you did want to use both, because you can, it's not a problem, you would type a second line right there where I'm at, transport space input space telnet. And that would have to mean both SSH and telnet working. Okay? If you wanted to do telnet, you just type telnet like you would normally do in the IP address. And if you want to use SSH, you would type SSH space -L, username, and whatever I just told you earlier. Okay. This setup works both on routers, switches, access points, firewalls. It's the same on all devices. Okay, so the same methodology, same commands.
Stupid question.
Mm-hmm.
If we're not implementing telnet, why would we implement line VTY? Isn't that the...
Well, that's just your sessions. You still have 5
Oh,
sessions.
okay.
But now the
That-
sessions
yeah.
are no longer using telnet; they're using now SSH.
Okay.
You still have 5 SSH sessions.
All
now.
right, I was thinking that implemented just...
No,
Oh, okay.
that
So I was-
implements
yeah.
implements your remote sessions.
Communications.
Communications, correct.
Okay, yeah.
Good question, though. All right, so far so good? Okay, let's go ahead and exit out. Let's do a service password encryption like we used to. We know that one already pretty good. That's good security. Service password encryption should always be something you do. Let's do a banner. MOTD, authorized access only. Also good practice. Everybody got it? Okay, no longer will we ever, from this point onwards, install DHCP on a router. Those days are over. Okay, it's bad practice. DHCP is broadcasted. Everyone know what broadcasting means? It's pushed out. You know, it's like streamed out to the world. Anybody listening will hear it, including the hacker. Well, we know that DHCP has quite a lot of sensitive information. Gives them their gateway, your DNS server, and your whole pool of IP addresses. And it's like almost giving them the key to your front door. It is. So the reason we did it the whole time is because that's what we were practicing. We were just practicing it for the ICND1 and ICND2. But in reality, not good practice. So where are we going to set up DHCP from now on? On a server. On a server. On the server itself. All the way at the end. So that's why we're going to finish up the router real fast now with all the interfaces. And I'll start you on the path, and then you can finish it up. You should be able to. From, you guys are all hardened ICND2 guys. So I'll just get you going. And then you'll finish it up. So what we're going to set up, what we're going to do on this device only, what's left right now, will be all the interfaces, both for the VLANs and the WANs, and then OSPF, obviously. OSPF is the choice, and then we'll save it. And then the router is done for the day. Okay? So let's go and get started. Now remember, we have two. We have two interfaces. We've got 0, 0, 0, and we have 0, 0, and we have 0, 0, 0, 1. So 0, 0, and 0, 1. Remember? We have two of them.
What
Okay.
about the serial?
And we have one serial. Well, only one serial. Yeah.
Three interfaces.
Yeah, with the 3 interfaces total, but two fast Ethernet.
Yeah,
That's correct. Let's do the serial first. Since it's not normal practice, we did. Let's do the serial. It's only one. So interface. Serial, okay, and 0/0/0. Hit enter. Everybody have that? Okay, we do not need the clock rate because that's going to be where on the ISP. Let's put a little description in there, always helps. You know, this interface connects CR1 to the ISP, to ISP. Then IP address 1.0.0. Let's do number 2 because usually the ISP gets the first one for simplicity. So we use the second one available to us as 2. So 1.0.0.2 and then space 255.255.255.252.
No shut.
And then we hit enter. We do a no shutdown exactly. Well, not shit down. Well, sometimes you would think, you know, who knows. All right. So it should go up because the ISP is always live. The ISP side is always live, so it should go up pretty quick. It's always turned on. ISP should never be down. How you doing today, Mike? A little tired?
No?
Just very silent today.
I
Quiet.
think this is my interface.
He's concentrating.
I want
Just
that.
focused.
Go.
Focused today, huh?
I want this go.
This
It's in the wrong thing.
no.
No, it's in
That-
Description.
It's working on security, that's all.
Okay, there you go.
Description.
If I can figure out my kids change the password on a computer, on, it'd be better, on it.
Yeah, yeah.
That's good security.
Good security, good security.
Once you get a break, I can make a phone call.
And the other one's already in there. I got
You
two.
you put the address in?
Yeah,
Okay.
Oh, no, catch up, don't worry.
I'll just do it again.
Yeah.
That's it right there.
Yeah, that's right.
Always wonderful.
Something else happened.
I know, it's tough. All
Yeah,
right,
tough.
so everybody have that?
Not now, but before. I can't remember.
Did you do no shit then?
That's right. Oh, no.
Okay.
I actually feel like an idiot now, but it's okay.
Why?
But it's because I am probably an idiot.
Uptight.
It's a long day too for me as well. So you know what we're gonna do, guys? No, we're not gonna change a lot because I'm not in the mood for that. Everybody grab that server right here, server 1.
Cool.
Pop it
Don't
over
even have a
here
thing on it.
on 4 right now. So on 4. Everybody bring server 1 to 4.